Hello, I'm Liao. Welcome back to Evan of Code 2023. We are working on puzzles every day, and today is day 2. So, let's take a look at what challenges await for us at day 2. Day 2, Cube Conundrum. You're launched high in an atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow, and an elf runs over to greet you. Hi! So the elf explains that you have arrived in a snow island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here, so would you like to play a game in the meantime? As you walk, the elf shows a small bag of cubes, which are either red, green, or blue. Okay, so each time you play this game, he will hide a secret number of cubes for each color in the bag, and your goal is to figure out information about the number of cubes. To get this information, once the bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, and show them to you, and then put them back into the bag. He'll do this a few times per game. You'll play several games and record the information from each game. So this is the information, your input. Each game is listed with ID number, so this is the ID, and then this is the number. And like in 11, in game 11, right, followed by a semicolon separated list of subsets of cubes that were revealed from the bag. So semicolon separated. For example, the record of a few games, it looks like this. So in game 1, you have 3 sets, because 1, you have 2 with semicolon and 3. And then put back again. The first set is 3 blue, 4 red, and then second set is 1 red, 2 green, 6 blue. And the third set is only 2 green. Okay. The elf would first likely to know which games would have been possible if the bag contained only 12 red, 13 green, and 14 blue. So in this example above, 1, 2, 5 would have been possible. However, game 3 would not be possible because because you have more, you take out 20 red, which is not possible when you have only 12 red cubes. And similarly, game 4 would also have been impossible because you take out, here in this turn, you take out 15 blues, which you only have 14 blues, so it is impossible. So once you know which games are possible, you add up the IDs of a game that would have been possible, and you get 8. So game 1, 2, and 5 is possible, so 1 plus 2 plus 5 is equals to 8. So determine which games you would have been possible if the bag has been loaded with only 12 red cubes, 13 green, and 14 blue. So what is the sum of the IDs of those games? Okay, let's write our code. Get your puzzle input. Let's copy this. Let's go into our code. Let's create a new file called day2 puzzle1.js, and this is our input. Paste this in, and then let's analyze the code. Let's parse this. So I'm gonna go through every line of input.split, and then for each line, you're gonna figure out what is the game and what are each turns, right? So we can figure out the game. I think we can use regular expressions over here. I like regular expressions. So here we can do the game number, and then we can also parse out, let's see, the game and the turns equals to the line.match game, and then this is what we want to capture. Over here, we're gonna capture the game, which game it is. This is digits, as many digits as we can take. And then we have a semicolon. And then we have a space. And then we have turns, right? So everything else, until the end should be the turns. Okay, so over here, after we match, we get the game, which is the first capturing group, and turns, which is the second capturing group. We have this. Then what we need next is to figure out whether the turns are possible, right? With whether this game is possible. So we have only 12, 13, and 14 blue. 12 red, 3 green, and 14 blue. Let me see how we should capture this. Red, green, blue. Okay. I think I'll say the requirements is equals to red is 12, green is 13, and blue is 14. Okay. And here we have the game. Then for each turns can be separated by semicolons with a space, right? Yep. So what I'm gonna do here is we're gonna loop through the turns as well. Turn of turns dot split with a semicolon. And for each turn, we have this is the string, and we're gonna parse this out. I think this one is also seems like it's comma separated, right? Here we have red, green. This is blue, red, green. These are all comma separated, so I'm gonna split by comma separation as well again. Of turn dot split by comma separation. So each peak, what you get now is this part. Okay, so here we have a digit and the color. So again, we can parse that out with regular expressions again. So this is the amount, and the second is the color, equals to line peak dot match. This is our capturing group number 1. And then secondly, we're gonna capture the color. So this will be any character. Or rather, instead of non-white space, I'm just gonna say any character. Here now we get the amount and the color, and we're gonna check whether the amount matches the requirement. So if requirements that of the color is greater or equals to the amount that we picked up. Oh wait, if it's less, then something is wrong, right? This is impossible. This game is impossible, so we're gonna continue with the next game. So here we need to continue the outer loop. So here I'm gonna put a label for the outer loop, and we're gonna continue this game. Continue game. And if it's possible, if we go through all the turns and everything is possible, then we are gonna add the sum for the games. Okay, so here I'm gonna say let's sum equals to 0, and here sum equals to the game. And let's see whether we can run this. Okay, note day 2, puzzle 1. We get 3099. So is that the right answer? Let's try. Yay! That's the right answer. Yay! Okay, so there we get our our third goal, our one gold star, and then we'll continue to part 2. Okay, so part 2. Let me save this. So let me clone this and create another file called puzzle 2. So all this code will be available on GitHub. You can find that in the description. And yep, so now we have puzzle for each of we have solutions for each day, and also puzzle for part 1 and part 2. And now let's work on part 2. So the elf says that they stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. So this is part of the story of the Advent of Code. So you can just show you how to get a water source to check it out yourself. So it's just up ahead. Let's continue to walk. You have to walk because you have to go up. And the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Right. So it's the same game, but what is the fewest number of cubes of each color that could have been possible, right? So in game 1, the game could have been played with as few as 4 reds, right? Because you took out 4, you took out 1, you took out none, 4 red, 2 green, because you took out none, no green, you take out 2 green and 2 green over here. So could have been done with 2 greens and 6 blues, because you take out 3, you take out 6, you take out none. Okay, so if any color would, even with 1 fewer cube, the game would have been possible. Would have been impossible, right? So each games, you have to go through and see what is the minimum amount that's needed. So the power of the set of cubes is equal to the number of reds, greens, and blues cubes multiplied together. The power of minimum sets of cubes in game 1 is 48, because let's see, we are possible with 4. So this is the multiply together. So right, so 4 times 2 is 8, 8 times 6 is 48. So the power is 48 for game 1. And then so this one is 1 times 3 times 4, it's 12. And then you get all the multiplications. And then adding up these 5 powers, 48 plus 12 plus this, produces 2286. Right, in each game, find the minimum sum of cubes that must have been present, and then we're going to get the sum of the power of these sets. Okay, so previously we checked whether it's possible or not based on the number of cubes that we pull out. Now we need to find the minimum amount that we needed so that we can pull out each of these. And then for each game, after we figure out the minimum amount that we need for each red, green, and blue, we're going to multiply the number together, the amounts together, and we're going to sum it up. Okay, so let's make changes to our code. So the sum part is okay. I think we are good with this. And for each turn we are taking, we're going to figure out. So here in each turn that we are picking up, we need to figure out the minimum amount that we need for red, green, and blue. Okay, so here I'm going to say we don't need these requirements anymore, so I'm going to remove this. And here in before we start the turn, look through all the turns, I'm going to create a map which is the minimum amount for each color. Minimum amount equals to red is 0, green is 0, blue is 0. So if you haven't played the game, then the minimum, if we didn't pull anything out, the minimum for each of the color is 0. And as we go through the turn and each peak, I'm going to check if the minimum amount for that color, right, is smaller than the amount that we pull out. Then we're going to say we're going to update this minimum amount to the number, the amount that we take it out, right? So this part, we're going to update this. And if you don't like this conditional, you can also use one-liner if you like one-liner, which is this equals to the maximum of either of the minimum itself or the number or the amount itself. Okay, right? So this to this and this is equivalent, because every time when you figure out that this is smaller than number, then the the maximum of both numbers will be the bigger one, which you will update, right? So if it's smaller, you update, right? So let me remove this thing. And after all the turns that we figure out, one thing we need to do is that over here, we need to figure out the multiplication of all colors. So here, the minimum amount of red times the minimum amount of blue times minimum amount of green will be the power of the cubes, right? And then this is then we're gonna sum it up, and then we're gonna print out the results. So let's run the code. This is puzzle 2, and we get this number. Gonna put this in, and let's see whether we get it right. Yay! This is a right answer. So you get 2 stars, and that's it for day 2. We have figured out and get 2 more stars. I'm gonna see you on day 3. Bye bye.